Alright guys, so today we are going to work on section 2.5, piecewise defined functions. It's very simple. A piecewise function is a function with some constraint. And if you look at the example number 1, what do we have? We have two constraints, x less than 0, right here, and x greater than or equal than 0. These two constraints define what function you will have to use when you will have to calculate f of a value of x. For instance, if you look at the example number 1 for a, we are asking to calculate the value of f when x equals minus 2. Obviously, when x equals minus 2, that means it's less than 0. So you will have to use the function f of x equal x minus 3. On the other hand, when you look at f of x, you have to calculate f of 3, which is the value of f when x equals 3. When x equals 3, it is greater than 0. And so you will have to use the value of the function of f of x equal x plus 1. Regarding the last one, f of 0, well, x equals 0. So you will have to use the function f of x equal x plus 1, as this function is defined on with the constraint x greater or equal to 0. Alright guys, now let's focus on the example number 2. What do we have on the example number 2? On the example number 2, we have to graph a function f of x equal x plus 2 if x is less or equal than 0, and f of x equal x minus 2 if x is greater than 0. So what we can do is graph these two lines. If I decide to graph the line number 1, we're having a slope m equal 1 and a y-intercept 0 plus 2. And for the other one, we have a slope m equal 1 and a y-intercept 0 minus 2. Because the slope are both equal to 1, you can expect that these two lines will be parallel to each other. So if I go to the point 0, 2, if I call that the point 1 and that 2, minus 1, minus 2, plus 1, plus 2. So the first one, from the y-intercept 0, 2, I need to go up 1 and right 1. So if I have to graph each of these lines, I will have to graph the first line right here. And the second one, if I decide to graph it in another color, I'm going to use a green. Alright, the second one, I'm going to start from here, and I need to go up 1, right 1. Alright. But the point is, these two lines exist only on a, depending, if I must say another word, it depends on the constraint. So if I look at the first one, it does exist only when x is less or equal than 0. So I'm going to erase up to here. And because there is an equal, I'm going to have a solid dot. Alright, right here, I got a solid dot. Okay. Now, for the other one, I know it will be, it does exist only when x is greater than 0. So up to there. But now I need to have an open circle because 0 is not a solution of this equation. Okay? I'll let you do the example number 1 now on your own. Evaluate f of minus 3, f of 3, and f of 0. As well as the example number 2, please follow the process. A piecewise function has to be entered as more than one graph and use inequalities sometime, including the end value. Inequalities can be found by pressing second and then mat, and can be found by pressing second, then mat, then going right once to logic. So follow the process right here, and you will be able to use the calculator. Alright. And you should have now in front of you, with your calculator, a graph looking like this. I'm going to try to do with you the graph number 4. I will let you do the graph number 3 on your own. So graph number 4, I need to graph the first line, which is m equal 1 and y-intercept 0, negative 2. The second one is a parabola, so I know this one is going to be a line, when the second one is going to be a parabola. And the last one will look like a square root function. So let's graph the number 1. The number 1, we're having x minus 2. So from the point 0, negative 2. So if that is negative 2, right here I'm at negative 2. I'm supposed to go up 1, right 1. So I'm supposed to have a line like this. My line is going up, my slope is positive. And then if I take a look at my constraint, it does exist only if, and actually I'm going to do this way like that. It does exist only if you have x less or equal than minus 1. So I'm going to erase everything until x equal minus 1, knowing that right there I'm at x equal minus 1. And because there is an equal, I will have a solid dot. For the other one, I have a parabola. I'm going to try to give a rough shape of my parabola, obviously because of the graph I have in front of me. But if you are looking at the parabola, you're supposed to have, when x equal 0, you're supposed to be here. Then when x equal 2, you're supposed to be at 4. So right there, x equal 2. You're supposed to be at y equal 4. 1, 2, 3, 4, right here. And when x equal negative 1, I'm supposed to be at 1. So I'm supposed to be right here. Let me just plot negative 1 under. Wow, here we go. Negative 1. And so basically I'm supposed to have, if I had to graph my parabola, it will be like this, with a more round shape on the bottom right there. And now my parabola does exist between minus 1 and x equal 2. And so I have to erase up to x equal minus 1 and up to x equal 2. I have to have an open circle for both because I don't have any equal. And now for the other one, I have square root of x for x greater than 2. So if I start to graph maybe I will have something like this. And obviously, because I need to represent from x greater than 2, I will have right there an open circle, and I need to erase pretty much everything before. Let me rewrite my x square function. There we go. Alright, so you know what? I decided to do the example number 3 with you. So for the number 1, we're having a slope m equal 1 and a y-intercept 0, negative 1. For the slope number 2, we're having m equal 1 and a y-intercept 0 plus 1. So far, from the first y-intercept, if that is 1, that is 1, 1, 1, we end up to have when x equal 1, I need to go up 1, right 1. Okay, so that will be the equation number 2. And that is okay only when x is greater than 2. So that is okay only right there. So there is an equal. It will be, you will have an open, closed circle, and everything else disappear. On the other hand, for the other one, let me erase the other one and use another color. M equal 1 and a y-intercept 0, negative 1. From negative 1, which is right here, for y, I need to go up 1, right 1. So that's supposed to be my line. And that line does exist only when x less than 2. So I'm going to go less than 2, and there is no equal on my symbol, so it's going to be an open circle. Alright guys, so I'll let you finish all the other example after completing the example number 3 and 4 and the example I done with you. I'll let you complete the other example that I didn't do. And regarding the practice problem, again, we will do some problem in class, and then we will define with you, and I will define with you. If you feel uncomfortable, well, try to do the practice problem on your note. Thank you very much, and talk to you soon.